All right, welcome back. Let's look at the second configurations of the structure of this system S. All right. Now, instead of having the A at the origin, we can have the B at the origin according to this diagram here. All right. Now, we will still have the two masses. One is 2m, the other one is 3m, attached to B and C. Let's look at how it look like. Okay, so 3m is attached to C, and then whereby 2m is attached to B here. Now, of course, as usual, we're going to set up the same um, reference frame. Okay, in such a configuration, where the B will be treated as the origin in this case. And then now, just as assumption, we may not know exactly where the center of mass for this rigid body is actually located. So let's look at our assumptions to the center of mass. Okay, let's assume that the center of mass is located somewhere here, where the x bar and y bar is stated according to this diagram here. X bar is the vertical distance from the line BC, whereby the y bar is a vertical distance from the line AB here. Okay, now by using the same uh, principle of moment, we are going to apply the same strategy here. We still have 17 overall, and then we have x bar, y bar as usual. Now that will be the same as the sum of all its individual components here. Okay, now I'm going to start off from AB again. AB has a mass of 3m. Okay, so that will be 3m, and then as usual, this center of mass for the wire AB is 1.5 A away from B, and then 0. And then next I'm going to move on to this one here. Okay, this is 4m. Now that will be 4m. That will be a 0, and then 2A. And then after that I'm going to continue on with the thin wire 5A of length 5A. Now the mass is 5m in this case. Right. So there will be 5m. Okay, that is located at about, I would say, now the drawing is not to scale here. So that will be roughly 1.5A and then 2A. Okay, and then finally I'm going to include the particle, both of the particle there. Now for 2m mass, because it's located at the origin there, so there is no center of mass, is just 0 0. Whereby the other one 3m, this one is located at the 0 4a. Okay, now if I'm going to conclude this, there will be 4.5a 0, and then this part will be 17 x bar y bar. I can get rid of all the m here, since the m is a constant. Okay, now there will be 0 8a, and then we have the 7.5a, and then 10a, and then after that 0 0. Then finally I have a 0 12a here. Then after that I'll have here 12a, and then this one is 30a. Therefore, the center of mass for this structure, based on this configuration, is 17. Oops, sorry. So 17 is 12 over 17. Okay, just let me correct that. Is 12 over 17a, and then 30 over 17a. All right. And then there you have it. Based on this configuration and the uh, frame of reference, we can conclude that the center of mass is located at 12 over 17a, 30 over 17a, with reference to the origin B here. All right, now I hope that is clear. And then next, to answer the next part of the questions, now the same thing. We are going to hang this structure at from A, and then it should be in equilibrium. Let's look at how it look like, and then what would be the angle um, made between the length, the side AB and the vertical. All right. Okay. Now I hope that's clear. Let's check out the next part shortly. All right. Before we move on, just to compare this answer with the answer that we have obtained from our first configurations, just to check whether it tally or not. Okay, now in this case, from our first questions, we are using A as our origin of reference in this case. So we found that the distance from the horizontal distance from A to here is given by 39 over 17, whereby the vertical distance, we notice that the vertical distance is still the same, because that is how far the vertical distance is from the line AB there. So we can verify that this 30 over 17 is correct. Now we just need to find out how far is this horizontal distance of this center of mass from A instead of from B here. Now I'm going to label this as XA bar here, just for reference from here. Now to get a XA bar, you will notice that there is typically just 3A subtract off with X bar here. That will be our X bar, according to this, is 17A here. Now that will be 51, so 39 over 17A. Which is exactly the same as our previous answer. Our previous answer is stated as this, with reference to A here, is written as 39 over 17A and then 30 over 17A. And then you can see that the center of mass never changed. It just the frame of reference is different. All right. Now I hope that is clear. I'm going to move on to the next section shortly. All right. Now the second part to this question here. Now let me show it to you how it look like. Okay. Now I'm going to change the view here. We are going to hang this system S about the point A here. Just let me show you a short animations to look at what we are looking at for this question here. All right. So if we were to hang this system S from A, we will see that the line would passes through the center of mass, and then at the same time passes through point A. Okay, this is where all the weight is assumed to be acting. Okay, so that will be a 17 m here. All right. All right. Now we know that the distance here. Okay. Now at this point, all right. Now it is still with reference to A. Then the answer that we have obtained for this second configurations state that the X bar. I just try to redraw this again. So this part is a Y bar. This part is a X bar. We have obtained this as X bar, Y bar as 12 over 17A. The other one is 30 over 17A here. All right, I hope that is clear. And then at the same time, if we use A as a reference, I have also shown that if we use A as a reference, this is the reading that we will get which is 39 over 17a, and then 30 over 17a. There's no change to the y component there. Now again, um, by looking at this structure here, if we were to label this as the center of mass, and then this part here as P, right? Now by consider the triangle um, PAC here, we can apply a simple trigonometry ratio to obtain this angle. It is the angle made between the line AB here, and the downward vertical. Right. So here we found that we can write a tangent theta as y bar A. I'm using this one here. Y bar A over x bar. This part here is x bar A. Just to be clear what we are looking at. So there will be a y bar A over x bar A here, which is 30 over 17a over 39 over 17a here, which yield 30 over 39. And then of course you can simplify that as a 10 over 13, and then therefore we can conclude that by using the inverse tangent, 10 over 13, and then that will yield 37.6, exactly the same angle that we have obtained by using our previous configuration. All right, now I hope that is clear for this point. And then next, do stay tuned. I'm going to show you the last configurations that we can have, and then how is it different from our previous two configurations. Does it tally with each answer or not? All right, stay tuned.